So my name is Dobrochna Fryc, and I'm at my final year of PhD studies at the Silesian University of Technology. Actually, let's say space sciences is not my primary subject of studies. I'm actually doing most of my job on biomechatronics, so I'm taking care of human motor system. I'm usually modeling the motor system using the inverse dynamics software. So, but I started my journey with analog astronaut missions a few years ago when I discovered a collaboration with LunAres Habitat in Poland, and we did some studies on stabilography parameters during the analog missions, and I'm going to talk about it now. So the title of my presentation is Stabilography Studies Results Provide Evidence of Chronic Stress During Simulated Space Missions. So the topic is actually connected the most with the topic of work environment optimization during the space missions. It's because the space mission is carries a lot of costs. So the main reason for conducting all of these analog studies is actually to figure out what can we optimize and how much can we optimize until we will send somebody into the space and pay a lot of money for them to spend some time up there. And we need to figure out how much we can optimize in order to avoid, let's say, the most harm to those people that are very expensive to train and also to send them to the space. And I'm not only talking about the costs like in money, but also the biological cost. And as a biologist, because I am an anthropology, like physical anthropologist, so I let's say think not only in those kind of categories of like money, but also when you change the environment and need to adapt, then you need to, let's say, pay some price, like biological price. So the space sojourns are very expensive, and we need to optimize that. So there is a lot of factors that influence people during the space missions, and probably are very familiar with most of them. So when we want to, let's say, plan some I don't know, let's say some kind of plans on a space station, we need to take into account that there is like different temperature, humidity, and also a lot of other factors that we need to provide the plant in order for it to grow, let's say, properly. And we are unable to give it all to this plant because, for example, the gravity is also quite needed for the plant to know where is the bottom and how to grow properly. But we can figure out how to like mitigate this aspect. But the human being is one of the most, let's say, complex organism on the planet, and there is much more elements that contributes to our well-being and the fitness. The word fitness is actually the term that describes the well-being of our species. And there is not only like those very commonly known aspects of our well-being that are like temperature and air composition and gravity and light exposure. We now know that we need, for example, vitamin D, etc. But there are much more elements that contribute to the fitness. For example, our territorial needs, our social needs, sexual and self-fulfillment. There are also much more aspects, but I'm not going to talk about them all. I just wanted to point out that there is a lot that contribute to our well-being. And also, I wanted to show you that the stress that I will talk about later is not simple to measure, and it's not simple to determine which aspects contribute the most. And I wanted to show you that it's important to know that this problem is very complex. So as a species, we have some kind of elements that are pretty common and that are determined by our genetic system. And for example, there are aspects that are specific for our species, and there are also those that can vary within our species. So for example, the need for example, for our territory, or for example, our physiological needs are specific, species specific. But for example, our individual needs are like some people need more space, some people prefer much less space, some people need much more contact with other people, and some people need it less. So there is some kind of variance within that. And also, when it comes to those needs, there are also some congenital and also some acquired, like imprinted. I can do some analogy. So, for example, some of you probably have a dog, and you probably know that there is like a very short window when you need to present most stressors to the dog in order for to avoid the dog to be afraid of many things later. So there are some stuff that we that are imprinted in us, and if we are not accustomed to some specific stimulus during our childhood, then something may cause us stress response, and we don't actually have any influence on that later on. So we need to understand that our stress levels are actually very complex, that we cannot actually say that somebody will respond a specific way to the specific environment, factors, etc. And that we need to distinguish at least the general aspects that we can mitigate. So when I said that there are many stressors and there are many factors that contribute to that, they all actually contribute to the main topic of the stress. So the stress level actually is responsible for our, I need to see, where is my, oh, this slide. Okay, so it all contributes to the topic of stress psychophysiology. So our psychological stress actually impacts our physiology through the sympathetic system that is like sympathetic and parasympathetic system are anatomically connected, but functionally it's like they have this opposite function. And the sympathetic system is responsible for stress reaction, and parasympathetic system is responsible for eating, for digestion, and for reproduction, and also for regeneration. So when the sympathetic system is activated with the stress, then our regenerative potential is actually reduced, and it can impact our health in a very different ways. So going back to this slide, I wanted to just point out that our body is in a kind of equilibrium, and we want to maintain this peaceful, let's say, state. But when any stressor comes, it can throw us off this equilibrium, and we need to have some kind of potential to mitigate this stressor. And any aspect that in normal condition will just be normally mitigated, in conditions of higher stress and lower regenerative potential, it can be it can be a harm for our body, and it can be destructive because we have much less potential to regenerate. So going to the when we want to talk about space mission and analog missions, there are some There are some differences, of course, and we know that the best difference is lack of microgravity during the analog missions. But actually, the literature shows that the stress response for both types of missions is quite similar, and you can see on the screen some aspects that were measured during the space mission. And those that are colored yellow actually are the same for analog missions. So you can see that there is increased heart rate and blood pressure. There is increased levels of stress response hormones, headaches, insomnia, eye-hand coordination disorder, increased muscle tension, and decreased in psychomotor performance. So all of those aspects are visible for both analog missions and also space missions. There's also decreased orthostatic tolerance during the space mission, and is very much microgravity connected aspect. But there is also atrophy of lower limb locomotor system visible, and it's actually also visible during analog missions, but in much less less scale. So as you can see, all of those things can be visible both in space missions and analog missions, and it shows that there is a lot of the part of the influence of the analog mission must be, and space mission must come from the isolation and confinement. And as you can see, it was enough to place people in a very narrow space and isolate them from the environment to achieve this almost the same stress response. So I wanted to do this introduction in order to show you the context of those studies, because the study is not very complicated. It was conducted during the mission when I was a commander. You can see now my crew. It was the best crew ever. So we did some studies, and there were participants also measured during the control group measurements at our university campus. So we measured stabilographic parameters in 10 consecutive days during the mission, and also 10 times once every day during the control group measurements on the campus. So we had 10 measurements from each participant, and we measured it with the Romberg test. It was the test that you need to stand on a platform that you can see now on the screen. And you need to stay calm for 1 minute and keep your hands near your body. And the Romberg test was performed with eyes open and eyes closed. So the Zebris platform alone allows you to measure the center of pressure and the distribution of the load on a platform. So the parameters that you can acquire from that kind of platform are center of pressure path that is usually presented with millimeters length, the ellipse area that is written around the path. Also, some parameters about the symmetry of the stance, and also some front foot, back foot proportions. So, as you can see in the results on the table, you can see that the values for analog mission were lower for almost all the parameters. You can see that COP and EA were always lower, and maybe not always for the closed eyes. The ellipse area was higher, but actually you can see that the values are lower for the no, they were lower. Okay, so you can see that the parameters were lower for the analog group, and And actually, you could think that it's okay, that it's better than the COP path is shorter, then it shows that the stability is better. But the interpretation of those results is quite different, because the stability that is better in the environment of analog space mission actually shows that the party is in a more alertness state. So it shows that the participants were more stressed. And you can actually see it in the stabilographic parameters. And it's very interesting, because usually to see that somebody is stressed, you cannot see it even in psychological tests. You need to actually either measure some kind of hormones from blood or from the saliva to figure out that there is a stress response. So actually, these results were very interesting, and it shows that not only we can see that the analog mission creates the great environment for testing people in higher stress environment, but also it provides us the information that stabilography actually can be used to detect higher stress, even if it's only the stressor of isolation and confinement. And the results are pretty nice. So you can see now, for example, which results were the most significant. So as you can see, for example, ellipse area with the eyes closed was significantly lower. And you can see, for example, this one graph that shows exactly the same as I told you. So the ellipse area was significantly less in analog astronauts. So I wanted to close this presentation with a few words about the potential of analog astronaut missions, because we measured only that there is a stress response connected with the environment of isolation and confinement, but there is much more to study in this topic, because we can, for example, isolate some other factors that contribute to those stress, and find out which one can be mitigated, even in a terrestrial environment, in order to implement the findings like in real missions. And I wanted to thank, of course, my team, my supervisor, Professor Michnik, and my friend Anna Miller-Banas, and also great friends from LunAres Habitat that were working with us during those missions. And also, I wanted to say that there is a lot of place for young scientists, and there is a great potential for studies in LunAres, and I highly recommend trying to find out something more about conducting studies there, because it's a great adventure, I would say. Okay, thank you very much.